we're going to just revisit gas stoichiometry. We talked about it in terms of Avogadro's law and being able to compare volume units versus mole units in a gas. But we want to just kind of work on this some more because it's very important that when you're working through a stoichiometry problem, if gases are involved, you've got another road to consider, okay? So, gases and chemical reactions, actually the section in your book is called Stoichiometry Revisited, okay? So what we have is another thing that we can do with the ideal gas law. We kind of took a break from this when we talked about Dalton's law of partial pressures because we have mixtures of gases when we're doing chemistry reactions like this. Okay, so we have a new leg on our Bridging the Gap map that we've been kind of constructing as we move along in these lessons. Okay, so let's realize that if you take that equation, PV equals nRT, we know that N stands for moles. And so if we could get P, V, and T together, along with the R that we always know, we could get N2 moles. So what I have called this road is PVT Boulevard. Okay, and we see we can come down PVT volume of our known. We can cross over that bridge over to the moles of an unknown. And if we needed to know the volume of the gas, or the typically that's what we'd look for, volume of the gas, we can go back up to volume of the gas using that PVT boulevard. But we won't always go from volume of gas over to volume of gas, and if we did, we could use that top row directly because we know that we could think about our coefficients in terms of volume units if they are gases. That only works if they're gases. So we could travel across the top and not have to go down there. Or maybe we're not wanting to know the volume of a gas of an unknown. Maybe we want to know its grams, in which case we have to go down that molar mass lane. So let's just work some problems where we're kind of utilizing this map. You want to have that map handy, get yourself familiar with the processes that you can do, plan out your travel plans, and then work through the problem. So let's do this one here. We're going to calculate the mass in grams of hydrogen chloride produced when 5.6 liters of molecular hydrogen, and it tells me it's at STP, reacts with an excess of molecular chlorine. Now they didn't give me a chemical reaction. We can't do stoichiometry unless we have a chemical reaction. So let's write the chemical reaction down that's happening here. It says it's molecular hydrogen. So we would write that as H2 because I know it's a diatomic molecule. It says it's molecular chlorine or chlorine gas. That's Cl2. So that is the two reactants. And it tells me I am forming hydrogen chloride, which is just HCl. And if we're going to balance that, we would put a 2 there, and now I have a balanced chemical equation. Now, what did they tell me in this reaction? I was given that I have 5.6 liters of the hydrogen gas. Now look at your map. You're starting with volume of hydrogen. So what we are doing is we're going to start with, I'm going to write it down here and kind of plan out my map here. I guess it doesn't really matter how I write it, but I'm going to put liters of H2, I know. And how many liters of that? That was 5.6. And I'm going to write here 5.6 liters of hydrogen gas. Now we've got two choices. We could go over the top bridge. Look at the map. We could go over the top bridge and go to the liters of HCl. That's one thing that we could do. And then we could go to moles. Look at your map. And then to grams. So we're going to go down that molar mass lane. So that is one way to get there. It's not the only way to get there. You could have chosen to go from 5.6 liters, look at the map. You could go down to moles using that PVT boulevard and travel over this way and then down. Either one is fine. It doesn't matter which you choose. Okay? Because there's more than one route to get to the grams of the HCl. Now let me look at my notes to see which one I chose to do. Oh, I chose to go across the top bridge. All right, so we have the 5.6 liters of hydrogen. I don't want liters of hydrogen. I'm going to go across that top bridge, so I'm choosing to do this route 1, 2, and 3. I'm going to go across that bridge, and I am going to go to liters of HCl. And since they are both gases, I use the coefficients of the balanced equation. I put a 2 here and a 1 here. And then I'm ready to go to moles. Now I've got two choices here of how to get to moles. I can use PVT Boulevard and get to moles. Or I could, and I'm just going to do this as a side note, since it says it's at STP, I could use this 22.4 liters per mole as a conversion factor to get to moles. That would be a little quicker. But I told you, you don't have to have that memorized. So let us not do it that way, and let's multiply this out. That would be 11.2 liters of HCl. That's just 5.6 times 2. Okay, now I have my liters of HCl, and now I can use PV equals nRT and solve for moles. So I'm using PVT Boulevard. So this step, if I use PV equals nRT, it's not a dimensional analysis term. It's a stop and do this calculation in the process. If I chose to do this, I could tack it on and get to moles of that, and it would still be a dimensional analysis process. So let us take what we're solving for. We're trying to get to moles. N is PV over RT. The pressure, it tells me it's STP, so that's 1 atmosphere. The volume, it tells me it is, well, that's what we just calculated here. It's 11.2 liters of HCl, because we're going to moles of HCl. We need the volume of HCl. The R we know, 0.08206, liter atmosphere per mole Kelvin. Writing that K reminds me I need this in Kelvin, and that's 273.15 Kelvin, because that's what STP means. And this is going to give me the moles of the it's not either. Yes, it is. Okay, so it's going to give me the moles of this gas, because I use this number, and that is going to give me a value of 0.50, and the units are moles of HCl, because this was the moles of, this was the volume of HCl. So now I know the moles of HCl, so I'm sitting right here. And then my last step would to be take the moles of HCl and go to grams of HCl. So we'll need the molar mass of HCl, and that's 36.46. That's 1 hydrogen and 1 chlorine, grams per mole, and that will give me 18 grams of HCl. Lots of different ways to solve the problem. I chose one. I chose to go over, down, and down here. I chose not to use this relationship, though I could have, and tacked it on here and just kept on with dimensional analysis. I chose to use instead PV equals nRT to do step number 2, so we'll just write this as step number 2 here. And then for step number 3, we moved on down the road to get to grams of HCl. I worked through doing stoichiometry when gases are involved. Now you're going to work through one. We have a problem here. It's kind of lengthy in its description, but I want you to pause the video and I want you to try to solve this one on your own and come up with an answer. Once you have an answer, then resume the video and I'll have something for you to answer about your work. Okay, so stop, work it, and resume. So you're back with me. Let's see. I want you to look at your work and I want you to tell me which one of these was the path that you took to answer this problem, okay? And if you can't recognize any of these as a path, we got some issues, but look through that and see what path you took to work the problem. Well, and go ahead and select one. D or E are both correct ways to get to the answer. We're trying to get to liters of hydrogen, okay? And so B wouldn't be the right answer for sure, because that's going to grams of hydrogen, so we'd eliminate that one. But in D, what we're choosing to do is go from grams to moles, and then on all the way up to the top bridge, to liters, and cross over the top bridge. Or E would go from grams to moles, travel across the smaller bridge, and then to liters of that hydrogen. That would be E. Now, I chose to go from grams to moles and then travel over the lower bridge, and that's the way I'm going to do it. But you might not need to look at my work, because did you get this answer of 10.7 liters? If you got 10.7 liters, you know what you're doing, you came up with a good method, you got to the answer, and you can stop this video at this point. But if you didn't get 10.7 liters, or you're like, oh, I got that, but I'm not sure I knew what I was doing, then you might want to watch me work through this problem for you. And so let's see what we've got here. I've got the problem rewritten up there that we can look at as we go through it. So we're starting with the given, and that is that we have 18.0 grams of the propylene, which is C3H6. The first thing I'm going to do is I'm going to go from grams of that to moles of C3H6. And I go to my periodic table, and I do 3 carbons and 6 hydrogens, and I have 42.09 grams in a mole. Now I'm going to go over the bridge from moles of C3H6 to moles of what they're asking about, the unknown. And in this case, the unknown is hydrogen. Now, as I look at the balanced equation up there, I see that it's a 1-to-1 relationship. So now I've gone over the bridge, and I have, at this point, moles of hydrogen. Now, I want to stop and actually get a number for this. It is 0.428, okay, and that is moles of H2. The reason I'm stopping there is because my next step has to be PV equals nRT. It's not just a tack-on dimensional analysis term there, because I don't have a way of going from moles to liters directly. I cannot use that converter of 22.4 moles in a liter, or liters in a mole, because this is not at STP. It has to be at STP to use that 22.4 value. So I'm going to, at this point, stop and use the PVT boulevard that it describes there. That means I'm going to use PV equals nRT to solve for what's being asked for. In this case, we're being asked for the volume of the hydrogen, or how many liters of that it is. So volume is nRT over P. The N I have at this point is 0.428. Okay, my R, 0.08206 liter atmosphere per mole Kelvin. My temperature, it says it's 24 degrees Celsius. That would be 297 Kelvin. And my pressure, it's 740 torr. I can't put pressure in torr here, because this has atmospheres. I know I need atmospheres. So I do 740 torr, and I'm just going to put the converter of torr to atmospheres right here in the denominator. There are 760 torr in an atmosphere. So now that gives me all the values that I needed. The units are going to cancel that I see along the way, Kelvin, Kelvin, mole, and mole. I will be left with the liters that I'm looking for here, and the value for this would be the 10.7 liters that we have. So there is the stoichiometry where we're incorporating PV equals nRT, and I call that PVT boulevard, incorporating that as one of the legs of my journey as I do the stoichiometry for these problems.